Welcome. Today, we're going to tackle one of the biggest ideas in all of software, object-oriented programming. And believe it or not, we're going to do it by talking about a cat.
Yeah, I know it sounds a little weird. What on earth does a cat have to do with writing code? But stick with me here, because by the time we're done, you'll see that understanding a cat is actually the perfect key to unlocking how millions of lines of complex software are designed.
Okay, so let's get right into it. The whole reason object-oriented programming, or OOP as you'll hear it called, even exists is to help us build software that mirrors the real world. It's all about modeling the things we can actually see and touch every day.
So, in the programming world, an object is exactly what it sounds like. It's a self-contained little package that represents something, anything really. And here's the absolute most important part. Every single object has two key things. It has a state, that's what it is, and it has behaviors, that's what it does. Let's go back to our cat. Its state would be things like its color, its name, or its breed. In code, we call these things fields. Then you have its behaviors, the actions it can take, like playing, eating, or meowing. And in code, we call those methods. See? The big idea of an object is just to bundle all of that, its data and its actions, together in one nice, tidy package.
Okay, but what if our program needs a whole bunch of different cats? It'd be a huge pain to have to describe color, name, breed, and playing, eating, meowing over and over and over again, right? Of course. So instead, we create a single reusable blueprint. And in OOP, we call that blueprint a class.
And this is the core difference you have to get. The class is the idea of a cat. It's the architectural drawing. The object, on the other hand, is the real thing you build from that drawing. It's your actual pet Fluffy sleeping on the couch. One is the template, the other is the instance.
So if a class is a blueprint, what's actually written on it? Let's zoom in a bit and look at the anatomy of the code itself to see how it's all put together.
Now, don't get too hung up on the syntax here. Just look at the structure. A class is really just a container, a box. It's the one place where we define all the things a cat is, that's its fields, and all the things a cat can do, that's its methods. It just keeps everything organized.
But the blueprint does more than just list parts. It also sets rules. We use these things called access modifiers to control who gets to see and use what. If something is public, well, anyone can see it, like a cat's color. But if something is private, it's totally internal. Only the cat itself can control it, kind of like its own heartbeat. This control is absolutely essential for writing code that's safe and predictable.
All right, so we've got this amazing blueprint, our class. But it's just a piece of paper, right? How do we actually turn that plan into a real, living, breathing, virtual cat? Well, for that, you need a special kind of factory. And that factory is called a constructor. It's a very special bit of code. Its one and only job is to get called into action, assemble a brand new object from the blueprint, and initialize its state. Give our new cat its name, its color, and all its starting details, right at the moment it's created.
Constructors are actually really easy to spot in the code. First, they always have the exact same name as the class. Second, they have no return type at all. And third, you'll always see them used with a new keyword. That's the word that tells the program, hey, fire up the assembly line.
The whole process is super fast. First, new carves out a little chunk of computer memory. Next, the constructor runs and fills in all the starting values for the fields. And finally, the system hands you back a reference, which you can think of like a remote control for your new object that's now living in memory.
But hang on, here's a super common problem you'll run into. What happens if the name of a parameter you're passing into the constructor is the exact same as the name of a field inside the class? Here, we're passing in a name, but the class already has a name field. How does the code know which one we're talking about? The solution is this little magic word, this. You can think of this as the object's way of talking about itself. So when we write this.name, we're being crystal clear. We're saying, hey, set my own internal name field to the value of that name parameter that just came in. It gets rid of all the confusion.
Okay, time for our last big idea. We've built our awesome cat object, but how do we keep it safe? How do we stop other parts of the code from accidentally messing it up or breaking it? That's where a concept called encapsulation comes in.
Encapsulation basically means we bundle the object's data and the methods that use that data all together, and then we build a protective wall around it to restrict direct access from the outside. It's like a cat's vital organs are inside its body, right? They're not just hanging on the outside for anyone to poke at. That's encapsulation. And how do we build that wall?
We use that private keyword we saw earlier. By marking the X and Y coordinates here as private, we've basically made it impossible for any code outside of this class to reach in and change them directly. They are shielded, safe, and sound.
Okay, this brings up a pretty obvious question, right? If we've locked all the data away behind this private wall, how on earth are we supposed to use it? How can we read the point's coordinates or, update them if we need to?
And here's the clever solution. We provide a controlled public doorway. We create special public methods, usually called getters and setters, that act as the official, safe gatekeepers to that private data. The getX method lets us safely read the value, and the setX method lets us change it, but we can build rules inside that setter to make sure the new value is valid. It's all about controlled access.
Now, there is one final piece to this whole protective shield idea. By default, if you try to just print out one of our new objects, you get, well, a bunch of gibberish. It's just the object's address in memory, which is totally useless to us humans. Our object needs a better way to introduce itself.
We solve this by giving our class a special method called toString. By writing our own version of this method, we can tell the program exactly how our object should be represented as text. And just like that, instead of some cryptic memory address, our cat can now politely say, "Hi, I'm a brown cat named Mittens."
So let's do a super quick recap. The class is the blueprint. The object is the real thing you build from that blueprint. The constructor is the factory that puts it all together. And encapsulation is the protective shell that bundles it all up and keeps its data safe. These aren't just random rules. They are the absolute foundation of modern programming. They let us build incredibly complex and reliable software by thinking about it in a way that just makes sense. So now that you have the blueprints, what will you build?